Hey, it's Mr. Shrum, and I am back again with a biology tutorial walkthrough. And today we're going to take a look at macronutrients and micronutrients. And with this lesson, we're going to explain or be able to explain why the human body needs both macronutrients and micronutrients to support homeostasis and the use of energy. So for a warm-up, we're asked, nutrition topics dominate the media. How do you determine whether a nutritional claim or product is too good to be true? What type of language do ads use that raise your suspicion? Well, with ads, they're going to give you the most positive spin on a certain product. And any claim that says doctors don't want you to know about this supplement, that should be a red flag for you, because if the food or product was that beneficial and safe and scientifically validated through a lot of experiments and test trials, doctors would most likely recommend it to their patients. Also, when an ad says that the product will bring quick results with little or no legitimate scientific data to support the claim, it usually means that the product is too good to be true. Now, on the smaller scale, there may be some beneficial supplements that are good for you, and the doctors may not go out of their way to recommend them to you, but it's usually their positive effects are a little exaggerated. So we'll talk a bit about that later too. But just be careful when it comes to advertising in general. And in the next question, we're asked, well, iron deficiency is one of the most common nutritional deficiencies in pre-menopausal women. Iron is a vital part of hemoglobin, which carries oxygen to red blood cells. Why do you think premenopausal women need more iron than men of the same age? Well, premenopausal women shed blood as part of menstruation every month, which lowers the level of iron in the body. So they need more iron than men and are also at a greater risk for this nutritional deficiency. So that explains why those with menopause or before they get menopause, they have to deal with menstruation, and that leads to blood loss, periodic blood loss, and you need to replace that with some type of iron supplement. But let's get into the macronutrients. Now, the word nutrient is often misused in advertisements about weight loss and dieting. A nutrient is a substance that an organism needs for energy, growth, and development. Nutrients obtained from food can be grouped into 6 categories. We have water, carbohydrates, proteins, lipids, also called fats, vitamins, and minerals. Water is an essential nutrient that dissolves all of the other nutrients and carries them to all parts of the body. It also carries waste out of the body and helps to regulate body temperature. Any nutrient that an organism needs in large amounts is called a macronutrient. In humans, our macronutrients are carbohydrates or carbs, proteins, and lipids, fats. They provide the body with energy. Oh, and here we have a nice little diagram of the types of proteins and carbs and fats. We got some bread action, some pasta, crackers. Could throw in potatoes in here. There should be more vegetables in the carb section, actually. Then you have your beans, lentils, eggs, apparently fish, meats, and then fattier cuts of meat, nuts, avocado. Yeah. Now, we're going to talk about calories. You may have heard of a calorie before, but you may not know exactly what it means in the science realm. A calorie is the amount of energy required to raise the temperature of 1 milliliter or 1 gram of water by 1 degree Celsius. The energy provided by foods or nutrients is measured in these dietary calories. A dietary calorie is equivalent to 1,000 of these types of calories. So think of this little calorie as the millimeter, and then this dietary calorie is like a meter, okay? So 1,000 of these little calories make up one big dietary calorie. A dietary calorie is sometimes spelled with a capital C to distinguish it from the calorie unit of measure. And that's where it kind of confuses a few people. In this lesson, the word calorie will always refer to this dietary calorie. The phrase burning calories refers to the body using energy supplied by the calories we eat. Heavy exercise burns a lot of calories because the body requires a lot of energy to do it. Even when people sleep, they burn calories because the body continues its basic processes. To maintain the same weight, the calories people consume must be equal to the calories they use. All right? And here's some examples of an hour's worth of exercise. Now, running for an hour is pretty strenuous for most people. So you're going to be burning plenty of calories. And jogging, but even just walking for an hour burns 245 calories. And even if you're doing nothing, your body is still using calories. So don't think that you have to exercise a whole bunch to eat a certain amount of calories. And we'll talk about how to estimate how many calories your body needs to maintain weight or lose or gain weight, depending on where you're at. Your calorie needs for weight maintenance can be calculated based on your basal metabolic rate, and that is known as your BMR. Your BMR is the amount of calories that your body requires to perform its basic processes and functions when at rest in a neutral environment. It gives the number of calories used by the body per day. And the BMR differs for men and women. You can calculate your BMR using the Harris-Benedict equation, and that is the one below. Note that the equation requires height and weight values in the metric system of measurements. using this conversion guide to convert pounds and inches into their metric equivalents. So here, this is the equation for males, and then we have females. And really it's this last input here, the +5 men and the negative 161 for the female BMR. And to calculate your BMR, use the table to calculate the amount of calories you need to consume per day. And it's important to remember that these are just estimates. No one's really sure how much to the specific number they need each day, but this will give you a decent starting point. So if you are a person that, doesn't get a whole lot of exercise besides walking maybe each day, but you don't play sports all that much, then you don't need additional calories besides your BMR, or at least that much more. So you would take your BMR, times it by 1.2, and that is your daily calorie need estimate. If you do like to exercise a few days per week, or you play sports a few days per week, you would need a little more calories to maintain your weight, since you are expending energy. And then if you're really into exercise 3 to 5 days per week, you'll multiply the BMR by 1.55. I would test these out first, see how your weight goes for a few weeks. If you're gaining a lot of weight, maybe you're eating too much. Unless that's your goal, then go right ahead. And then if you're losing weight, then that means you may need to eat more. So it's always an estimate, right? And even the food you put into your body, you're estimating. Those little calorie calculators, they're an estimate. So you can't be perfect, and that's okay. These are just guidelines, really. And then if you're an athlete of some sort, where maybe it's your job, or like if you're a professional athlete, or you work a very physical job like construction, maybe in a factory, just something where you're doing actual physical work for lots of days, and then you go out and exercise on your days off too, then that means you'll need a lot more daily calories. And then very heavy exercise twice per day. That's some intense, high level exercising. But most people, they're going to exist in this realm. Little to no exercise to moderate, maybe even heavy. But yeah, let's look at this question. Use the Harris-Benedict equation to estimate your calorie needs. Show your calculations to explain how you arrived at your answer. Oh, excuse me. So here we're given an example person. Brian is 15 years old. He is 5'8", so 68 inches tall, and he weighs 130 pounds. He engages in moderate exercise. Maybe he plays some soccer, or he goes to the boxing gym a few days per week. Who knows? Convert weight and height to the metric system. Right. So we have pounds and inches, but we need those in kilograms and centimeters. So we have the weight, 130 pounds. Multiply a pound by 0.45 to get the kilogram. And 130 pounds is about 58.5 kilograms. To go from an inch, you multiply an inch times 2.54, and you get 172.72 centimeters. And then, Brian, boy, so we'll use the male BMR equation. You plug in the numbers, and we get the BMR is 1,594.5 calories. So that's his basic basal metabolic rate. However, you have to calculate the daily calorie needs because he exercises a moderate amount. And the moderate multiplier would be the BMR right here times 1.55. So 1,594.5 times 1.55, that's about 2,471 calories per day. So look at the difference between the BMR and a moderate exercise version of that. Okay, so we're going to look at carbohydrates, proteins, and fats. These supply the highest number of calories and energy to the body. And first, we're going to talk about carbohydrates. Carbohydrates, or carbs, are the main source of energy in the human diet. These organic compounds consist of only 3 elements: carbon, hydrogen, and oxygen. The body breaks down carbohydrates into their simplest form, glucose, which cells then use as their primary source of energy. 1 gram of carbs provides 4 calories of energy to the body. And here we see chemical structures of main sugars. So we have glucose, fructose, sucrose, lactose, and maltose. There are 3 types of dietary carbohydrates. Simple carbs are often called sugars. They include monosaccharids and disaccharids. Some examples are sucrose, fructose, which is fruit sugar, the sugar in fruit, lactose, and high fructose corn syrup. These sugars are quick sources of energy because they're easily digestible. Your body absorbs them through the villi of the small intestine and then circulates them through the blood. Cells and tissues absorb the sugars from the blood to generate energy. Excess sugars are stored in the liver as glycogen, which is a polysaccharide. And start paying attention to these prefixes: mono, di, and polysaccharide. That tells you how many structures you're dealing with. So moving on, simple sugars can be obtained from natural sources like fruit, but they're also found in processed sugar added to foods like soda, candy, and syrups. Some canned foods that don't taste sweet, such as tomato sauce and ketchup, contain added sugar for flavor. So we had simple carbs. Now we have complex carbs. Now these are polysaccharides, and they can be more starchy, so starches. The body needs to break them down into those simple sugars first before the cells can use them. So we're dealing with whole grains like wheat, oats, barley, rice. These are all sources of complex carbs. Other sources are fruits and vegetables such as corn and potatoes. So these starchier, heavier carbs. Fiber is indigestible carbs found only in plant-based foods. Cellulose, a material found in the cell walls of plants, is an indigestible fiber. Because it's indigestible, the body can't use it as a source of energy. So fiber doesn't count toward calories. But this fiber does play an important role in maintaining digestive health by adding bulk to stools and allowing for the efficient passage of food through the digestive tract. A high fiber diet also controls blood sugar levels. It slows the rate at which sugars enter the bloodstream, and that helps protect against heart disease. So the more complex carbs are more fibrous or fiber rich. Fibrous foods, they will help you in your digestive health and are all around pretty healthy for you. So you do want a mix of simple carbs and complex carbs, and probably leaning towards more complex than simple. But sometimes simple carbs are okay. Proteins. Proteins are organic biomolecules required for the structure, function, and regulation of every cell in the body. Proteins form the cytoskeleton and the extracellular matrix. Within the cell, enzymes, hormones, growth factors, cell signaling molecules, transmembrane channels, receptors, coagulation factors, and antibodies are all proteins. Proteins are comprised of amino acids linked together by peptide bonds. If you look here, here's an amino acid chain. These proteins are comprised of amino acids, and they're linked together in these tiny peptide bonds. They are built from a collection of 20 amino acids, and the body can synthesize 11 of them. That means the body can create these 11 proteins, but the other 9 amino acids must be supplied through food. And those 9 that you need to eat are called essential amino acids. And if you click on the blue, experts are still debating whether there are 8 or 9 essential amino acids. But most agree that there are 9 because histidine can't be synthesized in adults. The 9 essential amino acids are histidine, isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan, and valine. So the body can create 11 of these proteins, but 9, the essential amino acids, must come from your food. Dietary proteins supply 4 calories of energy per gram, which is the same as carbs. But carbohydrates are easier to digest, which enables them to provide quick energy. Dietary proteins also provide essential amino acids, which are absorbed into the bloodstream. These proteins provide the essential amino acids to the body, and depending on the content of the essential amino acids, there are 2 types of dietary protein: complete and incomplete proteins. Complete proteins are foods that contain adequate quantities of all of the essential amino acids. Proteins derived from animal foods are complete proteins. They include meats, fish, poultry, eggs, and dairy products. Two plant-based proteins, soy and quinoa, are also considered complete proteins. Incomplete proteins are foods that lack an adequate quantity of at least one essential amino acid. Most plant-based proteins are incomplete proteins, but certain combinations of incomplete proteins can make a complete amino acid profile. For example, if you cook rice and beans, which most people do, I do at least, both lack a certain amino acid, but if you eat them together or separately at different meals, that will give you all of the essential amino acids, right? So rice has some essential amino acids, but not others. And then the beans have some, but not others. But they have the ones each other don't have. So they complete one another. And that's really all that means by incomplete proteins. If you have a diet with enough variety of food, you should be fine. If you're not interested in eating more meat or dairy products, or if you're lactose intolerant or anything like that, there is a healthy way to eat incomplete proteins and get all of your essential amino acids. And lastly, you have your fats. These are also called lipids. They are long hydrocarbon chain biomolecules obtained from the combination of one glycerol molecule with 3 fatty acids. They are insoluble in water. Fats are an important dietary requirement because they supply 9 calories per gram of energy. These are the most calorie-dense storage form available for the body. And all forms of dietary fats are broken down and absorbed in the villi of the small intestine. Within the body, fats play a number of roles. They form structural components of the cell membrane, provide insulation to organs, absorb and transport fat-soluble vitamins, and provide essential fatty acids. Essential fatty acids are linoleic acid, alpha-linolenic acid. I think they misspelled that. The body can't synthesize these fats and must obtain them through dietary intake. The body uses these essential fatty acids to build omega-6 and omega-3 fatty acids, which play key roles in tissue functions. So here we have nuts, cashews, olive oil, avocado, and salmon, which is a fattier, oilier, has more oil and fat than other cuts of meat. So depending on the bonds between the carbon atoms, dietary fats can be categorized into 3 types. We have your saturated fats, and in these saturated fats, all carbon atoms are saturated by hydrogen atoms. So there's no double bond between the carbon atoms. Dietary fats that tend to be solid at room temperature are saturated fats. So think of fats from meat, lard, cheese, and butter. These saturated fats are solid at room temperature, and then you can melt cheese and butter, but you have to add heat, right? So those bonds are saturated hydrogen atom carbon bonds. The body can synthesize all the required saturated fatty acids, so excessive dietary intake of these fats is not recommended. A diet high in saturated fats may lead to an increase in LDL, which is your low density lipoprotein cholesterol levels. Accumulation of LDL cholesterol in the artery walls narrows the arteries, and this is called atherosclerosis. The resulting restricted blood flow increases the risk of heart disease and stroke. So excessive saturated fats can restrict your blood flow in your arteries and cause all types of heart-related issues. Here is the chain, the saturated fatty acid. And here we see the stages of that atherosclerosis. So here's your artery. We have blood, but then you see this cholesterol substance building up, and that is cholesterol plaque. So this is the initial stage, and here's a significant atherosclerosis. So there's a lot of cholesterol building up in this artery, but blood is still able to get through. However, the last stage of atherosclerosis, if there is a blood clot and all this cholesterol builds up, that is complete blockage in your artery, and that is not what you want at all. That can only cause you issues and problems. So make wise health choices. Some people are a little more prone to heart disease, but a lot of it is dietary. Right. So that was saturated fats. Let me click out of that. And then we have unsaturated fats. These unsaturated fats have one or more double bonds between carbon atoms. There's monounsaturated fat. They contain one double bond between carbon, and then polyunsaturated fat contains more than one double bond between carbon. These dietary fats tend to be liquid at room temperature for unsaturated fats. So think of olive oil and other vegetable cooking oils. The oils from fish, nuts, seeds, and avocados also happen to be rich in unsaturated fats. And these are called heart-healthy fats. The two essential fatty acids, omega-6 fatty acids, or linoleic, omega-6 fatty acids, and alpha-linolenic acid, omega-3 fatty acids, are polyunsaturated fats. Consumption of foods containing unsaturated fats maintains a good balance of cholesterol in the blood, but they should still be limited because of their high calorie content. So you do want to consume a certain amount of fats, but overdoing it on the fat intake can negatively affect your health in several ways. So there needs to be a balance. Now, getting into trans fats, these are saturated fats that naturally occur in small amounts in foods like meat and whole milk. Artificial trans fats are produced by adding hydrogen to unsaturated fats, such as vegetable oil, to make them solid. For this reason, they're also called partially hydrogenated oils, or PHOs. And if we click on the blue, Because of the harmful effects of trans fats on health, the US Food and Drug Administration, the FDA, declared partially hydrogenated oils, PHOs, the primary dietary source of artificial trans fat in processed foods as not generally recognized as safe, or GRAS, for use in human food in 2013. 2 years later, in June 2015, the FDA announced that food manufacturers had been given 3 years to remove PHOs from their products. It's important to note that this ban is specific to the United States, and other countries have their own restrictions. So it's still important to be aware of how many trans fats are in the food you eat when traveling abroad. That is the interesting thing about traveling from country to country, is their health department or health administration has slightly different guidelines into what goes into their foods. Yeah, well, anyway, moving on. Trans fats are easy to manufacture, and they increase the storage life of foods and give food a desirable taste and flavor. So it's pretty easy to see why so many manufacturers or food producers take advantage of trans fats. If it's easy to manufacture, easy to use, it makes your food last longer, and it makes your food taste good. Of course, they're going to try to use it regardless of the health consequences. But thankfully, we have scientists that study these types of things. Trans fats are also used widely to deep fry foods because they can be reused several times. All of these factors make trans fats beneficial for food manufacturers. So if you've ever tried to cook something at home or fry something at home and use cooking oil, that cooking oil is cooked off and you can't keep reusing it. But if you've ever seen deep fryers, they just use that same oil again and again to fry all of their products. So another reason why food manufacturers like to use trans fats. But many medical personnel consider artificial trans fats dangerous because they act like saturated fat in the body. Its presence in processed foods increases the chances of developing heart disease. So these act like the saturated fats. And eating too many trans fats, the artificial trans fats, can lead to heart disease as well. And we're going to talk about cholesterol, right? We talked a bit about that in the atherosclerosis part. But now cholesterol. That is a lipid molecule manufactured by all the cells in the body. Cholesterol is also in some foods that we consume. Most animal-based foods, such as beef, pork, poultry, fish, shrimp, egg yolks, and cheese, contain cholesterol in varying amounts. They travel within the body through the bloodstream in the form of two types of lipoproteins: LDL, which is low-density lipoproteins, and high-density lipoproteins, or HDL. An increase in the levels of LDL cholesterol may lead to atherosclerosis and increase the chances of heart disease and stroke. So LDL, the low-density lipoproteins, leads to artery blockages and other types of heart and stroke-related issues. Extensive research has shown that trans fats and saturated fats are bigger threats to blood cholesterol levels than actual dietary cholesterol. But some people, as many as 1 in 3, might be sensitive to dietary cholesterol levels. The recommended dietary intake of cholesterol for a healthy adult without heart disease is 300 milligrams per day. Next, you'll watch a video about how to read food labels. I can't watch this video on here because it may be copyright restricted. Directions. So this lesson activity is actually really good because we'll practice looking at nutrition labels of snacks to determine which one she wants to eat. So we're told in part A, Brianna's doctor advises her to eat no more than 30 grams of carbs per day for her snacks. Because dietary fiber doesn't negatively affect blood sugar levels, she doesn't need to count it toward her carbohydrate total. If Brianna eats 2 servings of each of these foods, will she fall under her doctor's recommended limit for her snack? Explain your reasoning. So let's look at these foods. Food 1 on the left. The serving size is 5 ounces, 310 calories, 15 grams of total fat, 2.6 grams of saturated fat, carbohydrates. So if she eats 2 servings of each of these foods, if she eats 2 servings of this, she'll eat 24 total carbs from food 1. If she eats 2 servings of food 2, she'll have 14 carbohydrates from this one. So she eats 2 serving sizes from each food, each separately. So she eats 2 servings from food 1, she's under 30 grams. If she eats 2 servings from food 2, she's under 30 grams. But if she has both, she has 2 servings from this and 2 servings of that, that will put her over the carbs. So she can't eat 2 servings of each. Brianna's doctor recommends that she eats 28 grams of fiber per day. She's already consumed 60% of her fiber recommendation for the day. If she consumes 2 servings of each snack, will she meet her daily fiber recommendation? So 28 grams of fiber. And she's already eaten over half of it. Well, 2 servings from this would put her at 2 more fibers. And then 2 of this would put her at 4 grams of more fiber. So 2 plus 4 is 6. So she would be pretty close. %60 of 28 is 16.8. And if you add 2, you get 18.8. And you add 4 is 22.8. So she's actually not going to consume enough of her fiber for the day just through this snack. She's about like 4 grams under. 4 or 5 grams under. the doctor wants her to eat 30% or less than 30% of her total calories from fat. She's following an 1,800 calorie diet. So let's look. So 1,800 calories, 30% of 1,800 is 540 calories from fat. So she eats calories from fat here. So if you double this, there's 200 calories in 2 servings of this, and 300 calories from fat in 2 servings of this. So 200 plus 300 is 500. So she will be eating under 500 calories if she has consumed 2 servings of snack 1. Yeah, she'll be under if she eats 2 servings from food 1. Do you think percent daily value is a useful tool, even for people who don't consume a 2,000 calorie diet? I think yes. It'll give you a decent baseline of how much food is, how much of each macronutrient or nutrient is in the food, even if it's based off of the 2,000 calorie diet, because then you could estimate it backwards too. So if you're like 1,800 calories, then it's a little less than these two. So I think the daily value is useful. Well, that is the end of the macronutrient part. And I'll take a break and then we'll get back to the micronutrient part. I will see you guys later and good luck with everything. Bye.